Measles and biodiversity. Does one size fit all? During the course of putting together this lecture series, I came up with a thought, perhaps leading to a hypothesis. I want to share it with you, and perhaps you can go away and consider it, perhaps even test it in the future. The greatest force that shapes the development and the integrity of our immune system is microbial encounter. And we've evolved accordingly. So our exposure to bacteria, to viruses, to parasites, these things have shaped the development and health of our immune system. In fact, interestingly, what's emerging now is that rather than just being things that we have in our gut, bacteria, which outnumber our own cells in the body, not only are responsible in largely developing our immune system, but also our brain, our patterns of behavior, and our mood. So no man is an island. Our gut bacteria are essential to our health. Early microbial encounters are modified by factors ranging from the mode of delivery as a baby, antibiotics and vaccines. For example, if you are born by vaginal delivery, you acquire your mother's fecal flora, healthy fecal flora that colonize your gut. If you are born by caesarean section in a hospital, you are much more likely to acquire not your mother's gut bacteria, but hospital-acquired bacteria, which are inherently very much less likely to be healthy for you. Antibiotics given freely to infants and children have a profound effect, not only on the bacteria that they are seeking to bring under control, if that was the source of the child's problem, but also upon the healthy gut bacteria, producing profound disturbances, and vaccines too. And as for microbial infections, rather than just microbes per se, it's important to recognize that in a few generations, this initial encounter, this educational exposure of the immune system has gone from being wild type or natural infection to largely being replaced by vaccination. Now, during the course of this lecture series, a further question arose out of a number of seemingly unrelated observations, and so, as promised, I will leave you with questions. Here is the first one. For every child who dies from measles in Europe, some 400 children will die in an epidemic of a similar size in an African country south of the Sahara. Why? So why is measles so severe in Africa? We've explored some of these reasons. They are, on average, at risk of younger exposure. And not only is younger exposure a problem because the immune system is not so mature, but as we've discussed, one is at higher risk for intensive exposure to measles virus. Malnutrition is more prevalent in sub-Saharan Africa, particularly vitamin A deficiency. There is also a high risk of secondary bacterial complications when living in insanitary living conditions. Is there another factor, though? Is there something else operating that defines this risk? What about autism and early MMR exposure, the fraudulent CDC study that hid the fact that early exposure to MMR vaccine on schedule as recommended by the CDC between 12 and 18 months produced a highly significant increased risk of autism in African American boys? Not a finding that they expected, but nonetheless an alarming and highly significant effect. And what about the experience of the Yanomami, where there was an apparent horizontal transmission following vaccination with the banned in America Edmundston B vaccine with a very, very high mortality? Why this susceptibility? Is there another factor, one perhaps determined by our genetic makeup, that influences our immune responses that might help to explain these disparate observations? What about this? Who is this character? This is a parasitic worm found in the intestine of children largely in sub-Saharan Africa and the Amazon and Orinoco basins. Very, very common in those regions. Now, what's fascinating about this worm is that what protects people against parasitic infection like this is an exaggerated, a biased T helper cell type 2 response that produces antibodies. And the antibodies coat the parasite and allow it to be expelled from the intestine, preventing killing of the tissues. It also protects the host against damage mediated by these large extracellular parasites as they migrate through the body. So, a T helper cell type 2 response, that antibody-producing humoral immune response, is selectively protective against these parasitic worms. Epidemiological studies in the late 20th century showed that the susceptibility to helminthic infections, these worms in terms of the burden, is a genetic trait. Evidence for a genetic predisposition to infection comes from ethnic variation and susceptibility. For example, differences in susceptibility to helminth infection between ethnic groups was noted in the early 20th century in studies in the southern United States, where a much higher prevalence and intensity of hookworm infection was observed in people of European compared with African ancestry. Others have suggested that man's ancestors lived in an environment where infectious tropical diseases, such as parasitic worms, would have been common. And in this hostile environment, genetic selection for an increased T helper cell type 2 immune response occurred. They argued that in more temperate areas, these pronounced responses would have been less important and selected against. They suggested that this would have been due to an increased mortality in those areas from an overly vigorous response to a harmless or less common environmental agent. And I would take issue with that. I would say that in those temperate climates, there was more likely to be a bias towards a Th1 response because the prevalent organisms in those environments benefited or required for their eradication or their elimination from the host an adequate T helper cell type 1 response, and that includes measles virus. So little science has actually been done to directly determine whether healthy Africans or African Americans exhibit a biased Th2 response. But in one small study comparing healthy African children and adults from the Gabonese rainforest to healthy European children and adults from Austria, Wilfing and colleagues reported that whereas T helper cell type 1 lymphocytes reacted in both African and European adults, the T helper cell type 2 response reacted only in African adults. And that would tend to support the idea that there is this exaggerated T helper cell type 2 in those of African origin. It would be of more than academic interest to know if this is true, if there is some underlying propensity to an adverse reaction to measles or indeed the vaccine that led, for example, to African American boys having a greater risk of autism in the face of MMR vaccine on time, then there is clearly something of pragmatic value that can be done to change the risk. So, an excess B cell response protects against parasites. But imbalance is a problem because what that does is displace the immune response away from an adequate cytotoxic T cell response that immune system might then encounter in the presence of measles virus. And that may well lead to inadequate viral clearance and a more severe disease. So imbalance creates problems. What protects against one thing may indeed be a risk factor for another. And this has led really to Dr. Gregory Poland's field of adversomics, actually saying at the genetic level, one size does not fit all. We are fundamentally different, and we can anticipate, it is intuitive, that our immune response and our risk of adverse reactions to vaccines is going to be different according to a number of things, including our genetic makeup. And this field was based upon the initial observations that, for example, American Indian populations are more reactive to measles vaccine than Caucasian populations, generating a higher temperature on average. leading to the emerging field of adversomics, which by definition is the immunogenetics and immunogenomics of vaccine adverse events at the individual and at the population levels respectively. And Dr. Poland has hypothesized that adverse reactions and events may not be random, but may in fact be partly genetically predetermined. A new and important field. It will likely make a mockery of the one-size-fits-all approach to vaccination that has ultimately caused, I believe, great harm and in large part precipitated the waning public trust in vaccine policymakers. And so here are the questions. Did populations at high risk of parasitic infections evolve a biased T helper cell type 2 response that protected them from those infections? And does this inherited response put them at a higher risk of an adverse outcome to measles and adverse reactions to measles containing vaccines? Why autism in boys? Is there a differential immune response between the sexes that is part of this? And is this effect modified by age, since risks of adverse outcomes to measles and measles vaccines, as we've seen, are age-related?